Let's consider how we might use Hadoop in a traditional commercial environment. We know Hadoop was developed with web properties in mind, so the Facebooks and Yahoo and Google. Let's consider how we might use Hadoop in a commercial traditional application, and then look at a reference architecture of how we might use it within our data warehouse strategy. Let's take the example of an e-commerce application with no big data components whatsoever. So here we have a commercial e-commerce site and our new user registry purchases. All this sort of structured relational data is being put into databases within the system. And that data, eventually, we get into our data warehouse. But what we're not putting into the data warehouse normally are the logs. So our logs contain every click, every user presses. There might be some clickstream data in here that we can take advantage of, but it's an enormous amount of data at a much lower grain than we usually would put in a data warehouse. So we take some of it out. Maybe today's log files go into our data warehouse, or maybe a week or something like that. But a lot of this data, we just kind of throw it out eventually. What might this look like if we incorporated a big data technology into this flow? Well, we would still have our highly structured relational data making its way to the data warehouse and being used in the site. But our log files, we might put that into an HDFS cluster. And this is kind of the store it all mentality. We're just going to store everything for, maybe not forever, but for a very, very long time. And because we've stored everything, we can start to go back and ask questions that we weren't able to do before. Like maybe a question, how did views for certain products increase when our TV ads run? This is data that we're not able to run in our data warehouse, maybe because we don't store enough of the data at a low enough grain. But now with the addition of the HDFS cluster, we've kept all that information and we can go back and reinterpret it and create things that maybe we couldn't do before. And then take that output and put that into the data warehouse for further analysis. So let's generalize that and think about what would a SQL data warehouse plus Hadoop framework look like. If we integrated Hadoop into our classic data warehouse and BI infrastructure, it might look something like this. Instead of using a SQL repository for our staging database, we might well use Hadoop HDFS. The advantage of that is we could land a lot of data there that doesn't have much structure. Sensors, crawlers, devices, bots, logs, all kinds of things. And then from there we could pull that out of Hadoop and put it into our data warehouse, and by using those MapReduce structures and bringing the query to the data and so on, we could probably make a lot more sense of all this unstructured data and actually get that into our data warehouse platform. Our users would still consume that data after it was refined into more of the SQL data warehouse and the cubes and reports and so on. As we discussed in the previous lesson, Scoop is really the technology based within the Hadoop cluster that can push and pull to the relational side, while Hive is really a tool that clients can use to pull out of the Hadoop cluster directly. And we can mix and match these a little bit. We could use Hive ODBC from tools within the data warehouse environment, or the Hive ODBC could be used from client tools such as Power Pivot to pull data directly into the client side.